Hello and welcome everyone to First Ed Tech. I hope all of you are safe and doing good. So today's video is going to be on SOC, System on a Chip. So what does SOC mean and what are the advantages, disadvantages and all those things? I'll be talking each and every detail about it. By the way, if you are new to this channel, please subscribe to this channel. It really helps me to get motivated and make more and more contents in tech industry. And please like and comment. Also click the bell icon so that whenever I upload a new video, right, you will be getting a notification of that. So with that being said, let's get started. So SOC, System on a Chip, what does it mean? I'm sure each and every one of you have heard this term before in several product launches of smartphones or IoT devices and whatnot. So system and chip, these two words are of importance here. What does system mean is, system is a conglomeration of complex electronic circuit embedded in a substrate, in a chip. That is system on a chip. Now what are those complex substances, what are those electronic circuits which are embedded on a substrate? I will be talking about that later, but for now understand in a simple term that it is a complex set of electronic circuits that are there on a chip, and this chip make a complete package, and this package is known as SOC. So what are those things which are there in SOC? The electronic circuits which are there in SOC and which makes the entire of SOC is the CPU, the graphics GPU unit, the RAM, the ROM, the IO unit, the network interface cards, all are packaged together. So all these separate units, right, are packaged together and embedded on a chip. Okay, that is why it is called as a complex electronic circuit embedded on a chip. So with that, let's draw an analogy with respect to our computer system, especially the CPU unit of a computer. So we all know the CPU is the computer's brain. If you don't have a CPU, you won't be able to power on a computer, right? Because you need a brain for that. So within a CPU, you will get generally a processor, Intel or AMD processor. You will get a RAM unit. You will get the hard drives, SATA hard drives. You will get the IO units, the USB and all the other peripheral IO units, the network interface cards and whatnot. So these are the things you will get in a CPU. So drawing an analogy with respect to computer CPU and SOC, you will get whatever is there in CPU basically on a single chip, and which is just like a coin. Maybe it's very small. So whatever is there in a CPU, most of the things you will get on a SOC. Okay, so what are the advantages of using the SOC? I can categorize the advantages of SOC in four main points. The first point is the latency. To explain you in a simpler manner, right, let's forget about SOC now. You'll be surprised, right? Let's forget about SOC now. Let's think that in a flat you have two rooms. In one room you are staying, in another room your friend is staying. Now you want to communicate with your friend into another room. The communication time or the latency of the communication will be very less, right? Why it is very less? Because you can communicate with your friend faster manner, since your friend stays in just the next room. But if your friend was staying in 10 kilometers distance, right, maybe if no phone was there, the communication would have been a lot more time taking. Consider the same thing in a SOC. In a SOC, the elements are so optimally located, the proximity between the elements, between the electronic circuits are so optimized. Okay, the latency is very low as a result of that. Since the elements are placed in a same substrate locally, the interconnection delays are minimized to a great extent and the speed is maximized. So that is the first advantage, the latency. The second advantage is performance per wattage. Per watt of power will deliver you more performance in case of a SOC. Why it is like this? It is like this because of the first point. The elements are placed locally on a single chip. So as a result of that, if one component wants to talk with another component, right, the amount of battery or the amount of power that is required for that communication to happen will be a great minimum extent if you compare the same with a CPU. So that is why the performance per wattage is a lot more optimized here. So one more thing which becomes utmost important when we talk about the power delivery or the power efficiency of the SoC is the architecture which they use. There are two architectures which we are talking about here are the RISC and the CISC. RISC is reduced instruction set architecture and CISC is complex instruction set architecture. SoCs use reduced instruction set architecture or the RISC architecture. It is basically comprised of very minimal or very simple instructions like load will do load, stored will do stored, and save will do save. This is the RISC architecture. Very minimal set of simplified commands. Whereas the CISC architecture is a little bit complicated and it uses complicated terminologies and complicated instruction sets. So since the architecture in which the SoCs are based on, right, relies on the RISC architecture, the power efficiency or the power requirement of SoCs are also greatly reduced. So SoCs are not so power hungry. Okay, so why it is required? Consider the scenario we want to make a smartphone. So for making a smartphone, what is required? We need storage, we need RAM, we need a processor, we need I/O inputs, we need networking cards, everything that is there in SoC we all need. But generally if we want to put a CPU in a smartphone, it's not possible, right? A smartphone is a compact computer in a way. So we need a mechanism to place all those things which will behave optimally in optimal temperature, in optimal situation. We need a mechanism for that. And the form factor of that chip should not be of a great extent so that it can't fit in a smartphone. So what is the way? You need some form of a SoC. So that is why SoC becomes very important in those cases. So that is why we need SoC in all the wearables, smart watches, the edge computing devices, the Internet of Things devices, the IoT devices. What I mean by that? So everywhere SoC is required because of its form factor. When you start learning about SoC, you will get a term known as POP, package on package. It is used in case of high performance SoCs or the SoCs which are very performance driven, which are very optimized in the real world scenario. So what essentially it means is you have two sandwiched layers. You have two layers. One layer will be a layer of RAM and the storage unit sandwiched on top of a SoC. So package on a package. These are especially used in case of high performance SoCs. So with regarding the fabrication process or the manufacturing process of SoCs, there is a special technology known as MOS, metal oxide semiconductor technology. So with the help of this special technology, SoCs are generally getting manufactured. So I hope I have answered most of the queries which you will be having with respect to SoCs. If you have more queries with the same, please comment down below. I'll be answering each and every comment for sure. And in detail, I will explain if you have more questions. So I hope you like this version of mine with respect to SoCs. By the way, let me know how you are liking this background. I got some feedback that you need to change your background. So I changed this background into a new manner. So I hope you liking my videos. Please subscribe to this channel. It really helps me get motivated. Take care. Bye bye.